So how can we now send such a request to the backend to save data there? Well, as mentioned, we'll use this HTTP object, so to say. And with the dot notation, we can now get access to a broad variety of features provided by the HTTP package. Most importantly, a couple of methods, which you see down there. Now, these methods allow you to send different kinds of HTTP requests. Because when you send an HTTP request, you can configure it. And most importantly, you can choose which HTTP method should be used. And you also find this in the official Firebase documentation. Now, which method does what will always depend on your backend. Some backends accept POST requests for everything, because in the end it's the backend logic, so the code written on the backend, that decides what happens if a certain kind of request arrives. Here in Firebase case, it's quite logical, and for example, sending a GET request gets you data, sending a delete request deletes data, sending a POST request pushes new data to the server, so stores new data there. Put would overwrite existing data, and patch would update parts of existing data. So therefore here, of course, if we want to store new data, we want to use this POST method here, which is provided by the HTTP package. Because this sends such a POST HTTP request, and that's exactly what Firebase wants to store data there. Now, to make this work, this POST request first must be configured though. And for that, POST accepts multiple arguments. It always wants a URL, which is of type URI, which is a special kind of object, and I'll show you how to create that object in just a second. That's the URL to which the request should be sent. In Firebase case, for POST, the URL looks something like this. HTTPS, then your project ID, then this part here, and then this part, which is also dynamic, ended with .json. And I'll show you how to construct the URL that belongs to your project over the next minutes. So that's the URL. But in addition to the URL, POST, for example, also accepts a map of headers, which is in the end just some metadata that can be added to the outgoing request, and a body object, which defines the data that should be attached to the outgoing request. And that will be important here because, of course, a POST request almost always needs data attached to it because it is about sending data to a backend. And of course, that data, therefore, then also must be part of the request. So here we'll start with the URL. And for that, we can add a new URL local final variable here, which can be created by using the URI class, which is built into Dart. And URI offers many special constructors, for example, an HTTPS constructor to create a URL that points at a HTTPS backend. So at a server that uses the HTTPS protocol. And that's what we need here, because Firebase wants a request that's sent to HTTPS and then something. Now that something part is the next part. Here, that should be firebase.io.com preceded by your project ID. Now to get the full URL up to this path, you can simply go to your Firebase project and there to the real-time database, and it's in the end now simply this thing here, which is your URL. So we can copy this and paste it in here, and we just have to remove the https:// part because that will be added automatically thanks to us using this HTTPS constructor. Now with that, we would be creating such a URL, but this is actually not the complete URL. Instead, we should add a second argument here, which now defines the so-called path, the part after the domain, so to say. So what you would typically add with a slash after the main domain. And here we got a special feature of Firebase. We can basically pick this path ourselves. For example, we could set it here to shopping-list, like this. And the only thing we have to add here, in Firebase case, is .json at the end. This is not Flutter specific, instead this is something required by Firebase. Now this part here, shopping list, is totally up to you. And it will basically create a subfolder, a node in this database, you could say, of that name. And you will see it here once we started adding some data. So that's now the path I want to add here. With that added, we got the URL to which the request should be sent. And now we just have to finish configuring this request. For example, by also setting the headers named argument to a map, where the keys are header identifiers and the values are settings for those headers. And here it's just one header which I want to add, content-type written like this, with a value of application/JSON. This will help Firebase understand how the data we're sending to it will be formatted. Last but not least, it's the data itself that's missing. For this, we should add another named parameter to post, and this is now the body parameter, which defines the data that should be attached to the outgoing request. And here, that should in the end be our grocery item here, though I'll format it a bit differently. Because body here actually wants data that's formatted as JSON, which is a special text-based data format. Creating data in that format is quite straightforward in Flutter and Dart because there's a built-in JSON utility object that is provided by Dart under the convert sub package, which you have to import. But with that added, it is available here. And you can now use JSON to call the encode method. And this converts data to this JSON formatted text. So it simply encodes the data to use this special format. For that, encode needs an object that can easily be converted, and here a map is a great choice because JSON encode knows how to convert maps to JSON. Therefore here I'll create a new map object on the fly by using these curly braces, and here I want to encode my key product data. And in my case, that's all that data down there. Name, quantity, and also the category, though for the category, I'll also make a change soon. But here I'll start with the name, the quantity, and the category. And in a map, the keys must be wrapped between quotes. So that's what I did here. And for the category, I'll actually just store the title, because otherwise it would be a complete object where encoding it might fail, and I'll therefore just store the title because I can then later use that title for mapping it to the actual category object when we then later load the data from Firebase again. So for sending the data, I'll just store the title because I'll be able to later use that title as a category identifier. And you will see how it's getting used once we start loading the data. And that's therefore now the data that should be sent to Firebase. We don't need to send the ID because Firebase will generate a unique ID for us, which is pretty convenient. Hence, this is all the data that needs to be sent. And at the moment, I will also not navigate back and I will not pass any data to POP. Instead, I just want to send this data. And if we now save everything with these settings and we restart the app, we should be able to enter some data here. And if we now click Add Item, here in the app, nothing happens. But if you go to Firebase, you should now see a new node in your real-time database here. In my case, called Shopping List, because that's the key I used. And if you expand this node, you see a new unique ID that was generated. And if you expand this item, you now see the data that was submitted. And this proves that sending the data succeeds. Now, if it fails for you, definitely take a look at the debug console and the error message you might be seeing there. Make sure that you are using your Firebase real-time database ID and not mine, so that you use your URL, not mine. And make sure that under rules, you don't have false here, but something like this. Or simply replace this with true. This will also allow all incoming requests. And that's what we want here for this demo backend. And with that, we are able to store data here on Firebase. Now let's also see how we can get that data back.